Welcome. The topic we'll be discussing in this lecture is DHCP, Dynamic Host Configuration Protocol. It is specified through RFC 2131, Request for Comments 2131. Mainly DHCP is used in mobile IP for identifying or for allocating COA, care of address. Okay. So So DHCP is mainly used to simplify the installation and maintenance of network computers. Okay. It basically simplifies the installation and maintenance of networked computers. If a new computer is joining to a particular network, then DHCP can provide it with all the necessary information for integrating that new computer into the network. When a new computer is joining a particular computer network, then DHCP will provide all necessary information for integrating the new computer with the network. Okay. So what kind of information DHCP provides for integrating it with the network? In the sense, so typically it provides these informations for the new computer which is joining the network, so that the new computer can be integrated with the uh, network. Okay, the information includes address of the DNS server, default router, subnet mask, domain name, and IP address. So it provides the address of the DNS router, DNS server, default router, subnet mask, domain name, and IP address. So basically 5 things it is providing. Okay. Out of this, IP address makes DHCP very attractive. Providing an IP address makes DHCP very attractive for mobile IP. For mobile IP, because the ability to provide an IP address by DHCP, because of that ability, DHCP can be used as a source for providing care of address for the mobile station when it moves from one network to another network. Okay. So the attractive part of DHCP in the context of mobile IP is its ability to provide a care of address. So now DHCP protocol can be used by mobile IP for allocating care of address for the mobile nodes whenever the mobile node moves from one network to another network. Okay. So let us see this diagram. So this diagram shows how DHCP works. So basically DHCP is based on a client server model. So whenever a new client is joining some other network, then the DHCP client will send a request. It is the client is called as DHCP client because it is sending a DHCP request. Okay. It sends a DHCP client, it sends a request to the server, and this request is nothing but a DHCP discover message. Okay. It sends a The client will send a request message. This request is nothing but a DHCP discover message. Okay. To which the server responds, and the server will respond for this DHCP discover. Okay. So the client sends request using MAC broadcast to reach all devices in the LAN. The client will send the request using MAC broadcast, through which the request will reach all the devices in the LAN. Okay. Sometimes a DHCP relay might be needed to forward request across inter-networking units to a DHCP server. Sometimes if the client is not directly connected with the server, then a relay may be used to pass these messages between other inter-networking devices. Okay. So once the server receives the DHCP discover message, it will respond with some other message which is called as DHCP offer. So basically, this is how the client will identify the DHCP server, and then it will connect with that. So DHCP server is the one which provides all the information, like the address of the DNS server, default router, subnet mask, domain name, and IP address. Okay, so let us see how exactly the communication between the DHCP server and the client happens through a process called as client initialization. So this timing diagram shows how the client is allotted to a particular server and how it is getting initialized itself. So let us assume that the client has moved into a new network and it want to connect to a DHCP server. So first it sends a DHCP discover message. First it sends a DHCP discover message. So first it will send a DHCP discover message which will be received by all the DHCP servers in the network. So in this diagram, we are considering that there are two DHCP servers out there. So both the DHCP servers were receiving this message and they are determining their configuration parameters. Like what are the services they can offer. They are representing that through a configuration parameters. So the configuration parameters or the services offered by different servers may differ. Okay, so based on these configuration parameters, they send some reply. They send a reply to the client. They send a reply to the client through the packet DHCP offer. So the DHCP offer will include the configuration parameters of different servers. So this server will set some configuration parameters, whereas this server will set some other configuration parameters. Now the client has received two DHCP offer. Now the client has received two DHCP offer. One is from this server, say this is server 1, and one is from this server, say this is server 2. Okay. Now the client out of these two servers, it will identify only one server. It has to accept the connection only from one server. Okay. So I mean it should accept the configuration parameters only from one server. So let us assume that in this case, the client is going to accept this configuration parameters of server 2 and it is going to reject server 1. So whichever the one it is going to accept, it should send a DHCP request with the options, like all the configuration parameters and what are the features it needs. Okay, so it will send a DHCP request with options, whereas the server to which it don't want to get the details, to that it will send DHCP request reject. So both two servers has offered. Of that two, the client is rejecting one server and it is accepting the another server. So when the client is rejecting, it will send a DHCP request reject message, and when the client want to accept, it will send a DHCP request options message. Okay. Now the server 2 receives the DHCP request options, and then it will respond with a DHCP acknowledgement. Then it will respond with a DHCP acknowledgement. So once all these steps are done, so it means that the initialization phase is completed. Now the client has joined this particular network. Okay. Now the point is, whatever the configuration parameters the DHCP server is providing to the client, it is actually time bound. It is actually time bound. So it means the configuration parameters will become invalid after a certain amount of time. So even after a certain amount of time, if the client needs all those configurations, then once again it should place a request, DHCP request to the server, and it should ensure that the configuration parameters are retained. Okay. And if the client want to no more want to be a part of this network, if it is leaving this network, then it can just send DHCP release. Then it can just send DHCP release. Sometimes what happens in the sense, so the client will leave the network without sending DHCP release. Okay, and then the configuration parameters will not be freed from that client. Okay, so that is the reason why there is a time bound. After the time bound, the configuration parameter will expire. So once again, the DHCP client should request for the configuration parameters. Okay. Otherwise, whether the client is still there or not, all those things the server don't know. So that is the reason why the configuration parameter expires after a certain period of time. Okay. Yeah. So once the DHCP release was received, the server will free the context stored for the client, uh, and it will free the context. Okay. And the configuration a client gets from the server is only leased for a certain amount of time. It is time bound. It has to be reconfirmed from time to time. So after several times, if it expires, then it should again the client should again reconfirm. Otherwise, the server will free the configuration. Okay. So this timeout of configuration is required because sometimes the client may get crashed, or the client may move away without releasing the context. Okay. So this is how DHCP works. DHCP is a good candidate for supporting the acquisition of care of address for mobile routes. Okay. Uh, the, the the same thing holds for other parameters needed. So not only care of address, for getting other parameters also DHCP is a good candidate. Okay, such as the address of the default router, DNS server, timer server, etc. Okay. A DHCP server should be located in the subnet of the access point of the mobile node. It should be located within the subnet of the access point of the mobile node, or at least a DHCP relay should provide the forwarding message, or at least it should be the client should be able to connect to a DHCP server through a relay. Okay. So authentication of DHCP messages is also very much required. If DHCP messages are not authenticated, then it cannot be protected from malicious DHCP servers. Okay. Sometimes somebody may act as a malicious DHCP server. They may not be a DHCP server. To get the client data, they may act as a server, and they may do some malicious activity. Okay. Without authentication, Without authentication, the mobile node cannot trust a DHCP server, and also the DHCP server cannot trust a mobile node. Okay. Without authentication, the mobile node also cannot trust the DHCP server, and the DHCP server also cannot trust the mobile node. So that's it about DHCP, Dynamic Host Configuration Protocol. So basically, this is used in mobile IP for acquiring the care of address, COA. And then we have discussed how a new client will get a new address by using DHCP, by using various messages like DHCP discover. So initially, client will broadcast DHCP discover. For that, the server will respond with DHCP offer with the configuration parameters. Out of that, the client will accept any one server, and it sends either a DHCP request or a DHCP option based on the configuration parameters. So whichever the server it don't want to connect, for that it will send DHCP reject, and for the other server to which it is going to connect, to that it will send DHCP options. And for that, the server will respond with a DHCP acknowledgement. So this is how the initialization is done, and the client will got an COA, that is care of address. And once uh, everything is done, finally client will send a DHCP release to delete the particular context. So let us stop here. Thank you.